Alright, so today we're going to start on section 2.6. This is a 2-day lesson, okay? So today we're going to get halfway through it. Actually, no, we're actually going to get through the entire thing, but next time is just going to be more practice, okay? Alright, you do have a quiz next time, okay? Yes, so this will be part of the quiz. What's that?
But it's not going to be a big part of the quiz. We haven't practiced.
No, it will. Yeah. Alright. Anyways, so rational functions, okay? You are familiar with rational functions. We talked about them last time. A rational function is going to be in the form of f of x equals n of x over d of x, where d of x cannot be 0, or that your denominator can't be 0. And n of x and d of x are polynomials of x, okay? Remember that to find the domain of a rational function, you must find the values that would make the denominator equal to 0, and those are the values that you cannot have as part of your domain, okay? This lesson should be relatively review for you, okay? It should not be anything new, I hope, for you, okay? Alright, so number 1 and number 2 is finding the domain. If you're just finding the domain and I'm not asking you to do anything else, the only thing you should really do is just take the denominator and set it equal to 0. And find out what values will make your denominator equal to 0. So in this case, I'm going to take x squared plus 9x plus 20 and set it equal to 0. Which means that this factors out to be x plus 4 times x plus 5. Correct? So that means that your domain is all real numbers except x cannot be what? -5 and -4. And that's going to be set notation. What if I ask you an interval notation? How would you write this?
Negative infinity.
And beyond.
-4. No, -5. -5. Union. -5.
Good. Union. -4 to infinity. Okay. Remember, on the quiz, you need to be familiar with either or. I could ask you either or. Okay? And if I want to be real picky, I can ask you for both.
Well, hold on. You're
Oh.
actually going to grade upon which notation we use?
Yes.
What matches it?
Me. Alright, find the domain of the second one. Positive. Alright. Now, because this is not the first time I am teaching you this, notice that I kind of summarize everything that you should know. Okay? This is not the first time you should be seeing asymptotes, but I'm going to remind you of all the rules. Okay? Now, I know that you're probably not like, some of you guys may be a master at this, may really remember everything. Some of you guys need a refresher. What I'm trying to say is that this is not the first time I'm teaching you. You should be seeing this, so I'm not going to sit here and really into detail. And typically this in Algebra 2 takes about a week and a half for you to learn, and we're going to cover it in one day. Okay? Alright, so first of all, you should remember from rational functions that there's such things as asymptotes and holes. Okay? Now, in order for you to find vertical asymptotes, okay, the graph of f of x is going to have a vertical asymptote at each real 0 of the denominator. Okay? So to find all vertical asymptotes, set the denominator equal to 0 and solve for x. That's going to give you your vertical asymptotes. Okay? Alright. For horizontal asymptotes, there's 3 different scenarios that could occur. Okay? And it's all going to consist on the degrees of the numerator versus the degree of the denominator. Okay? If the degree of your numerator is less than the degree of the denominator, then you're always going to have an asymptote at y equals 0. On the other hand, if the degree of the numerator is exactly the same as the degree of the denominator, then you're going to have an asymptote at y equals a over b, where a is going to be the leading coefficient of your numerator, and b is the leading coefficient of your denominator. So for example, if you had something like y equals 2x squared over x squared, notice how the degrees are the same. The leading coefficient of the numerator is 2, the leading coefficient of the denominator is 1, so 2 over 1 is 2, that's where your asymptote will be located, at y equals 2. Okay? Yes, the leading coefficients. Okay? Last one. If the degree of the numerator is bigger than the degree of the denominator, you do not have a horizontal asymptote. Okay? So if the degree is greater than of the numerator is greater than the denominator, then you don't have a horizontal asymptote. You actually have another kind of asymptote. Okay? Alright. Lastly, holes. In order for you to find a hole in a graph, if you have a common factor, for example, x minus a is a common factor between the numerator and the denominator, that means you're going to be able to cancel those terms out, correct? Which means that that's where a hole is located. If you're able to cancel something out from both the numerator and the denominator, you're going to set that factor equal to 0, and that's where your hole is going to be located. That's going to give you the x value where it's located. To find the y value, I'll show you guys here in just a minute when we practice. Okay? So, those are all the rules that you should remember, or at least try to go back to your Algebra 2 skills and see if you can apply them. Okay? Alright, what I did after this is I actually gave you some tips on how to graph. Okay? This is what I typically like to do. Again, you don't have to do things exactly the way I do, but this helps me to stay in track of everything that's happening. Okay? So typically what I do first is I like to factor the numerator and the denominator. That's the first thing I do. Okay? The second thing I do notice is that I actually find where the holes are first before I do anything else. Okay? I like to find out where the holes are for a couple reasons. Because if I find out that something is a hole, then I won't make the mistake of calling it an asymptote, because you can't have an asymptote and a hole at the exact same value. Okay? So that's the reason why I find holes. Holes are basically, they overtake the asymptote. They're stronger in a way. Okay? After that, then that's when I go ahead and determine where my vertical and my horizontal asymptotes, and I put them on the graphs and put dotted lines on my coordinate plane. The third thing I do, and most importantly, is that I find the x and the y intercepts. Now, one of the things I want to bring up is the reason why I find the holes first is that if you cancel out some of the terms between the numerator and the denominator, when you're trying to find your x-intercepts, that hole will no longer be part of your graph. And I'll show you what that means when we get to a practice problem. Okay? Finally, once I put all my asymptotes, I use a test to test each section. And I'll tell you what that means here in just a second. Your asymptotes are going to break a coordinate plane into different sections. So if you can create a t-table where you plug in values, you're going to be able to test, and you're going to know where your graph is located. Okay? Alright, lastly, I don't do this as much, but instead of erasing, I typically, for a hole, what I do is I just put a little circle, and that lets me know that's where a hole is. If you want to erase, it's up to you. Okay? Most importantly, I want you to highlight this. Remember that you are graphing a function. You must pass the vertical line test. If you're done with your sketch and you can't pass the vertical line test, you must have done something wrong. Okay? Remember, you have to pass the vertical line test. And this may be new to some of you guys. You were told that asymptotes, you can never cross them. That's what most of you know. But in reality, there is one type of asymptote that you can cross. You may never ever cross a vertical asymptote. You can't. But you may actually cross a horizontal asymptote. Okay? You may actually cross a horizontal asymptote. Alright, so let's practice some of this. Okay, number one, very simple. Let's look at this. You have f of x equals x plus 2 divided by x minus 1. Do you have any holes present?
No.
No, you don't, so none. Okay, alright, next thing, asymptotes. Do we have a horizontal asymptote?
Yeah.
How do you determine horizontal asymptotes?
The degree.
The degrees, right? So what are the degrees of your numerator and the denominator? 1. Here's the degree of 1, right? Here's the degree of 1. So when the degrees match, what do? Look at the leading coefficient. So the leading coefficient is 1 on the numerator, and so is on the denominator. So 1 divided by 1 is... So that means that you have a horizontal asymptote at y equals 1, okay? Now, vertical asymptotes, what do you do to find vertical asymptotes? Set the denominator equal to 0. So I'm going to say x minus 1 equals 0, which means x equals, so you have a vertical asymptote at x equals 1. Okay? So what I'm going to do is I'm going to go ahead and plot this asymptotes on my graph. So x equals 1 would be here, and I would represent it by a dotted line. And y equals 1 would be located as such. Alright, now, before we get to x-intercepts, I think y-intercepts are easier to find. How do you find y-intercepts of any function? You plug in 0 for x, right? Do you agree that at the y-axis, the x value is always going to be 0, correct? So if you can plug in 0 for x, so that means 0 plus 2 is 2, 0 minus 1 is negative 1, 2 divided by negative 1 is, so that means that you have a y-intercept at 0, negative 2, correct? Alright, so 0, negative 2, I'm going to plot that value in here. I want to make sure I didn't lose anyone. We're okay with how I got the 0, negative 2. Alright, now how do you typically find x-intercepts? You set it equal to 0, okay? When you have a rational function, I like to do this. You don't have to do this. Instead of setting the entire equation, I set the numerator equal to 0. Because, think about it. If you have a fraction, the only possible way that you can have a 0 is if your numerator is equal to 0, correct? If you have a 0 in the denominator, then it's undefined. You can't have that. So regardless of what you have on the denominator, except for a 0, the numerator is what's going to determine if it's a 0, correct? So we're going to set our numerator equal to 0. So if you want to put yourself a reminder, set numerator equal to 0 to find x-intercepts. So if I set the numerator equal to 0, that would be x plus 2 equal to 0, which means x is what? So you have an x-intercept at negative 2 comma 0, correct? So I'm going to go ahead and plot in negative 2, 0, which is located there. Okay? Now, do you guys, first of all, before we keep going, now that we have all that information, when you're coming up with a sketch, what I like to do is first ask yourself, how many coordinate plane get broken into? 4. 1, 2, 3, 4. Now let me ask you something. You can obviously see that your graph is going to be somewhere down here because we have those 2 points. Okay? If we use the definition of an asymptote, first of all, this has to come towards this one, correct? And you have to approach the asymptote. So it has to go that way, correct? And then you have to approach the asymptote going that way, correct? Alright, now, ask yourself, is there any way that you can have anything that's part of your graph on this top section? Why not? Why can't I have something like this, for example? It will not pass the vertical line test. So you kind of have to use your reasoning. So that, using that reasoning, then you know that there's no way that anything can be there, because otherwise you will not pass your vertical line test. So now the question is the next part of your graph going to be on the top or the bottom? Okay, there are certain rules that you can memorize that tells you that if it's in the bottom, then next has to be on top, etc. But you can also just create an XY table, okay? And all you need is really 1 point in this case. You need an x value that's going to be on that part of the graph. So definitely we can choose 1 because that's where your asymptote is located. So the lowest value that I can pick is 2, whole number, right? So if I put in a 2 for x, 2 plus 2 is 4. 2 minus 1 is, so that means that at 2 you are at 2, 4. 1, 2, 3. Now, if you like, you can plug more points, but it's really not necessary. Okay, because all I'm looking for is a sketch. From this point, you know that you have to go up towards the asymptote, correct? And following the definition of an asymptote, then you have to come down as such, and then follow this asymptote on that direction. So your graph is going to end up looking as such. Okay? Will this pass the vertical line test? Yes, it will. Questions?
Are they ever, like, both going to be on the bottom half or both on the top half, or they always
Let me think about that for a second. No. They alternate. Alright, number 4. Alright, can we simplify this before we get started? Is the denominator factorable? No, it's not. Okay, so is there any holes? None. Alright, let's talk about vertical asymptotes first. Remember to define your vertical denominator equal to 0. If you set your denominator equal to 0, what's going to happen? X is going to be plus or minus I. Can you actually plot imaginary numbers? Graph them. Not on this type of coordinate plane. You will need an imaginary, right? Okay. So in this case, do you have any vertical asymptotes? Nope. Horizontal asymptotes. Do you have a horizontal asymptote? Yes, you do. Where? Remember, when your degree on the denominator is greater than the degree of the numerator, you're going to have an asymptote always at y equals 0. Okay? Remember that if you only have a constant, that means that your degree is what? 0. Okay? Alright, so now, x-intercepts. Are we going to have x-intercepts? We're not. And then think about this. If your asymptote is at y equals 0, are you going to have an x-intercept? No. Okay, so none. Y-intercepts. Yes, we will. We will plug in 0 for x, right? 0 squared is 0 plus 1 is 1. 1 over 1 is. So you have a y-intercept at 0, comma 1. Correct? Alright, now this is a funny looking one. So let's plot what we know. 0, 1 is here. We have an asymptote here. And that's all we know. Suggestions. What do you think I should do? Let's create an XY table. I agree. Alright, so pick a value. I heard negative 3 and I heard 2. Let's try those two. So at negative 3, if I put negative 3 here, that's 9. Plus 1 is 10, so it would be 1/10. Right? If I plug in 2, 2 squared is 4 plus 1 is 5, so 1/5. Alright, so negative 3, 1/10 would be somewhere very low here. Alright? 2 1/5 will be somewhere, let's say per se there. Do you think we need more points, or does this give you sort of an idea? Okay, if you don't see anything, what I would do, I have a feeling this is going to be symmetric. So what I'm going to do is I'm also going to pick 3 and negative 2, see what happens, okay? But you should already know what's going to happen, because those values are going to get square, right? So that means that at negative 2, you also get 1/5, and at 3, you also get 1/10, correct? So is this going to be sort of a symmetrical? It is. So you're going to be going in that direction, and you're going to rise, and then you're going to get there, and then you're going to go in this direction, and then go that way. If you need to plot more points just for you to feel better, I don't know, to get a better look at the sketch, then you may do so, okay? Can you have any part of your graph be below that asymptote? No. Okay? Yes. I would say yes, because it's a function and a function is continuous. Okay? Alright. Do you guys want to try a couple of your own? Alright, so try number 5 and number 6. Pause the video and then come back and check your answers. Alright, check your answers. This is what I got for number 5. You should have no holes. Vertical asymptotes at plus or minus 2. A horizontal asymptote of y equals 2, and then x and y intercept at 0, 0. I tested a few values on each one of those intervals. I tested negative 3, which is on this side of the asymptote, and I got about 3 3/5, so that's somewhere up here, so your graph should be located here. Because that 0, 0 was located here, that gave me a hint that my graph had to be below here, but I tested a value anyways. I put 1 and I got negative 2/3, so it means it's going in this direction. And then I tested the value number 3, which got me about 3 3/5, which is somewhere up here, and that means that your asymptote should be located on that. Okay. Number 6, first I factored it out to be x over x minus 3 over x plus times x plus 1. I'm sorry, which then showed me that you do not have holes. You have a vertical asymptote at x equals negative 1 and 1 located at 3. You also have a horizontal asymptote of y equals 0 because the degree of the denominator is greater than the degree of the numerator. You should have an x-intercept at 0, 0 and a y-intercept at 0, 0. So notice how I did not give you the sketch of this, and there's a reason. Wait, you have an x and a y-intercept at 0, 0, but you also have a asymptote. So that may be a little puzzling as to how to grab this. Okay? Alright, so let me show you what I would do. First of all, because that point is there, now you know that you can cross your horizontal asymptote. Okay? Now, since you have no clue where to begin, you're going to have to test values. Like, there's no way around it. Okay? So, let's start left. Okay? So, what would be a good value to test? That's to the left. We can do -3, why not? So, that means if we plug in -3 to a numerator, that gives us -3. Over the denominator, -3 squared is 9. Minus 2 times -3, that's plus 6, right? So that's 15. Minus 3, 12. So ultimately that gives you negative what? 1, 4, correct? So that means that at -3, you're going to be at -1/4. Do you need to plot more points, or do you think that's sufficient for you to know what's going to happen? You're going to go in such directions. Okay? Now, on this middle section, since you are going to be crossing, you're going to have to select a few more points. Okay? If we, let's say we put in 1. Okay? If we plot 1, that means on the numerator it's 1. 1 squared is 1. Minus 2 is -1. Minus 3 is -4. So that means that at 1, you're at -1/4. Okay? Now, you really don't need another point to know what's going to happen going on that direction, but you could if you wanted to. But this is going to go in this direction as such. Now, you don't need to plot another point, but you could if you wanted to. But if you wanted to, you could do -1/2 and see what happens. But I'm going to show you that this is going to go on that direction. Okay? This looks like the tangent. Okay. Now, let's go ahead and test value on the right hand side. So let's say if we put, I'm going to get rid of this one. If we put 4, that'd be 4 in the numerator. 4 squared is 16. Minus 8 is 8. Minus 3 is 5. So 4/5. So it's somewhere in here. So that means that your graph should look something as such. Okay? Questions, concerns? We're good? Alright, let's go ahead and move on. And now I'm going to introduce you to another kind of asymptote. Some of you guys may have seen it before, some of you may have not. Okay? Alright. They're called slant asymptotes, or also known as oblique asymptotes. If you hear either term, they're referring to the exact same thing. So, you knew that if the degree of the numerator was greater than the denominator, you did not have a asymptote, you did not have a horizontal asymptote, correct? Well, now I'm telling you that you have something called a slant asymptote. Okay? It says, if the degree of the numerator is greater than the degree of the denominator, the numerator is stronger and pulls the graph away from y equals 0. So that means the horizontal asymptote for the function where the degree is the same. When this pulling action occurs and the degree of the numerator is 1 higher than the degree of the denominator, you end up with something called slant asymptote. So how are we going to find them? In order for you to find them, you're going to take the numerator and divide it by the denominator. Okay? The polynomial part of the division answer, that's the part without the fraction, is going to be the equation of a line. That equation is going to be your slant asymptote. So here's what I mean. You're going to do your division. You're going to take your quotient. That's going to be an equation of where your slant asymptote is. You are going to ignore if there is a, I just went out of my head. If there is, oh my god. This is what happens when you know 2 languages. Like, I'm thinking in Spanish and I can't say it in English. When you have a remainder, Jesus, you're going to ignore the remainder, okay? Alright, let's try it. So this one, you can obviously see that your degree on your numerator is higher than the denominator. So you are, from here you know that you have a slant asymptote. Okay? So you're going to take the numerator and you're going to divide it by the denominator. Now notice on this one, the denominator was a degree of 1, so you could have used synthetic division. You could. There's not a problem with that. The reason why I use long division is because most of the times you're going to be dealing with divisions where the denominator is not going to be a linear factor, so you're going to have to be forced to use long division. Okay? So if we divide this, that's going to be x. X times x is x squared. X times negative 2 is negative 2x. When we subtract, those cancels out, and this becomes 5x plus 2. Plus 5, so 5 times x is 5x. That's negative 10. We're going to practice here in just a second. Okay? Alright. Okay? So number 8. Can we simplify this?
No. Wait, you can with the soap.
The soap? Isn't the top a sum of cubes?
That's what I was talking about.
So you could, but before we get there, let's just look at this, okay? Obviously that there is no holes. Can you guys see that? Like there's no holes, because nothing is going to cancel out. Let's talk about vertical asymptotes. Do you have any vertical asymptotes? Well, in order to find vertical asymptotes, isn't there 3 rules? And you can only have vertical asymptotes when the degrees are the same, correct? But they're not. Or the degree is higher on the denominator, correct? Which is not. So do you have a vertical asymptote? No. What's your horizontal asymptote?
Wait, so you can't have one, you can only have one if the degrees are equal or...
Wait, hold up.
Wait, can we go back to that? When can you not have a vertical?
Messed up, Doc. Yeah. Done messed up. I said sure, I was right.
Vertical asymptotes are the ones that go up and down, right? So my bad. Do we have a vertical asymptote? Yes, we do. I'm sorry. X squared equals to 0, so that means we have a vertical asymptote at x equals 0. That's on me. All right, horizontal asymptote. Can we have a horizontal asymptote? No, because our degree on the numerator is greater. I'm sorry, so it's none. Okay. So now you know that you do have a slant asymptote. So to figure it out, what must we do? The thing. We're gonna divide. So I'm running out of room, so I'm gonna go here. X to the third plus 1 divided by x squared. Okay. So that means that's x. X times x squared is x to the third. When we subtract, those cancels out, and that brings down 1. Can you keep going? No. So where's your slant asymptote? Y equals x. All right. X-intercepts. How do you find x-intercepts? Set the numerator equal to 0. So I'm going to go down here because I'm running out of room. So it's x to the third plus 1 equals to 0, which means x to the third equals negative 1. Can you take the third root of a negative number? Yes, you can. So the third root of negative 1 is going to be what? Negative 1. Alright, if you're puzzled, let's talk about this. Negative 1 times negative 1 is positive 1 times negative 1, negative 1. So you guys see how it's negative 1? So that means that you have an x-intercept at negative 1, comma, 0. Okay? Y-intercepts. Do we have any y-intercepts?
No.
No, you can't, because if you plug in 0, the denominator will be undefined, correct? So none. Alright, so let's plot what we know. We know that we have a vertical asymptote at x equals 0. We know that we have a slant asymptote at y equals x. Well, you should know that this is the parent function, and it goes something as such. We know that we have an x-intercept at negative 1, 0. Correct? Alright. Based on that, you know that this part of the function has to be on this top part. you will not be able to have anything down here, otherwise you're going to fail the vertical line test, okay? You can find another point if you wish, but in reality, all you need to know is you can follow that way, correct? And then you have to go in this direction, okay? Now, because you know that you can't be down here, then either you're going to be up here or down here. So you can create an XY table to figure it out. If we put in 1 on the equation, 1 to the third power is 1, plus 1 is 2. 1 squared is 1, so 2 over 1 is 2. So 1, comma 2. So some of you guys went ahead and jumped and thought that it was going to be down here, right? Be careful. So that means that this is going to be going on that direction as such. I plugged in 1, and then I got 2. And then if you wanted to plug more values, you'll notice that you continue to get them up there. Okay? Test the values. Okay? It doesn't take you that long to test the value. Alright? Questions? Do you want to try number 9? It's a little bit tougher, but I think you can do it. Try number 9 and see what you get, and then come back and check your answer. Alright. So check your answers and let's talk about this. There's a few pointers I gotta talk about. First things first, you should have noticed that they try to trick you and they put the numerator out of order. The highest degree was 3, not 2. Okay, which means that the degree of the numerator is higher than the denominator, so that should have told you that you had a slant asymptote. Okay? Alright, second, when I factored everything out, on the numerator, I got x squared times x plus 3. On the denominator, I got x plus 3 times x minus 1. Which then would tell you that these two terms are going to cancel out, which tells you that you're going to have a whole at x equals negative 3. Now, the whole, you only have the x coordinate. You don't have the y coordinate. Okay? You can't really figure out where the y coordinate is until you graph, until you have your final product. Okay? So now, based on that, that means that you only have a vertical asymptote at x equals 1. You can't have one at x equals negative 3 because you have a hole in there. Okay? Remember how I told you the hole overtakes the asymptote. Okay? Alright. Now, again, I told you the degree is higher in the numerator. That tells you that there's no horizontal asymptotes. But you have a slant asymptote that after I did the division, I got to be y equals x plus 1. Questions on that? Okay. Next, x-intercepts. And this is very important. When you are setting the numerator equal to 0 to find your x-intercepts, you cannot include the whole. Notice how I did not include the whole. The whole's gone. You're only going to include what's left. In this case, we only had x squared left. That's the reason why I only took x squared and set it equal to 0. Okay? So that means that your only x-intercept is 0, 0, which automatically makes it a y-intercept as well. And if you plug in 0, that's the only thing you're going to get, right? Because you can't get another y-intercept, otherwise you will not pass the vertical line test. Correct? Alright, so here's what we know. I plot my vertical asymptote, I plot my slant asymptote, and I plot my x and y-intercept. Because my x and y-intercept is there, I automatically knew that this had to be down here. Okay? Now, the next thing I did is, well, I had a hole at negative 3. So at negative 3, you got to go down to where your sketch is, and that's where your hole is going to be located. You're going to draw a circle, or you're going to erase that part, whatever you want to do. I prefer you draw a circle, actually, so I can see. That's easier for me. Okay? Now, what I did after that, I tested a value just to figure out if I was on top here or on the bottom part. I plugged in 2, and I got 4, so 2, 4 is going to be on that top part, and then I drew my function as such. Okay? Alright, let's move on. We're almost done. Alright, so some of you guys are saying, well, how would I know if my graph can cross a horizontal asymptote or a slant asymptote? Okay? Because they can, the only asymptote that cannot be crossed, so now I'm going to improve on what you knew, the only asymptote that cannot be crossed is verticals. Vertical asymptotes are the only asymptotes that you cannot cross. Okay? Now, earlier you asked me, well, what's the point of the asymptote, what's happening? Okay, here's what's happening, and I'll do you a little sketch. So let's say this is a horizontal asymptote. I'm going to get a little bit ahead of myself, but towards the end of the year, we're going to start talking about limits, okay? When we talk about limits, you're going to first, right now, you don't really have a clear understanding, but what a limit is I'm going to give you a value, and you're going to tell me what's happening as it is approaching that value. So let's pretend that a function is approaching infinity. So what could happen is that this function can be approaching infinity, and it's going to get smaller and smaller because that's the definition of a slope, right? Not a slope, an asymptote, I'm sorry. It approaches it. But what happens sometimes is that it actually does cross, and it becomes negative. But it's such a little different that it comes back up. And then at some point, we continue to go to infinity, and it happens again. So in reality, you're still along that asymptote, so that's why the asymptote still exists. But you're having this, which is so minimal, but it can't cross. Cool? It's so minimal. Like, I can't really show you an example. It's like little, like it crosses negative 0.0000001, and then it comes back up to positive. It's so minimal. But my question, what I'm going to ask you is, I'm not going to ask you like to literally sketch the cross. I'm going to ask you, could it actually cross? Okay, and I'm not going to ask you how many times would it cross, because that's no. Okay, my only question to you would be like, can the asymptote be crossed? Okay, so how are we going to do this? Okay, to find out if it crossed, you're going to set f of x equal to the equation of the asymptote, whether it's a slant asymptote or is a horizontal asymptote, excuse me. You're going to solve. If the solution makes sense, okay, then that's the location where it'd be crossing. If you get something like 2 equals 3, would that make sense? No. Then that means that it will not be crossed. Okay? So let's talk about that. Alright, it says, find the horizontal and or slant asymptotes, then tell me whether it will cross those asymptotes, if at all. Okay? So let's look at the first one. Will you have a slant asymptote? No, you will not. Will you have a horizontal asymptote? Yes, you would. Because this is going to factor out to be x minus 1 over x plus 2, x minus 2. Correct? So that means that your horizontal asymptote is located where, guys? Plus or minus 2, right? Why do I keep doing that? Oh my god. It does have a vertical asymptote of y equals at x equals plus or minus 2. But you have a horizontal asymptote where? I'm sorry. Y equals 0. My bad. Jesus, why do I keep doing that? Alright, y equals 0. So now, what do you do with that 0? So you're going to set your equation equal to 0. So you're going to say x minus 1 over x squared minus 4 equal to 0. And solve. Now, there's a few ways you can do this. Okay? You can pretend that this is over 1. That's cool, right? You're okay. And you can do cross multiplication. Do you guys agree with that? So that would cancel out. But in reality, aren't you just setting your numerator equal to 0? Remember how earlier I told you that? Okay. So this is x minus 1 equals what? 0. So that means that x equals 1. So are you actually crossing? Yes, you are. Where? Well, yeah, because look at where your asymptote's located. That means that when you set it equal to 0, your x is 1. So that means that you are crossing at 1, 0 in this case. Okay, because your asymptote was originally located at y equals 0, so on the x-axis, right? So you having a point then tells you that it is going to cross. Okay? All right, number 11. Will you have a horizontal asymptote? Will you have a slant asymptote? Yes, you will. So we do division. X squared minus 1 divided by x. That's x. X times x is x squared. When you subtract, that goes away and you have that. So that means that your asymptote is what? Isn't this equation essentially y equals x squared minus 1 over x? Correct? We replace the f of x. Isn't that essentially what it is? You know what y equals to. So you're going to say x squared minus 1 over x equals to And if you want to make this, you can do x over 1. It's fine, right? Did I lose anyone? Are we cool? Now, what would you do from here? So wouldn't this be x squared minus 1 equals 2x squared, right? But if we subtract, wouldn't that be negative 1 equals to 0? Is that true? That is not true. It will not cross the slant asymptote. You guys want to try the last two? Alright, so try the last two.
So we don't have like a slant asymptote or horizontal asymptote?
Alright, go ahead and check answers for number 12. I got that it will not cross the horizontal asymptote. But for number 13, it will. It will cross. Okay? Homework for tonight is page 147, and that's the numbers. Thank you for watching.